A diamond planet is a planet that scientists believe may contain a large amount of carbon in the form of diamonds. The best-known example is 55 Cancri e, which orbits a star about 41 light-years from Earth. It is called a diamond planet because early scientific studies suggested that its interior might contain huge amounts of diamond formed under enormous pressure. However, this does not mean the planet is a giant gemstone, or that its entire surface is covered with diamonds. The idea is that deep inside the planet, where pressure is extremely high, carbon may have crystallized into diamond. Scientists continue to study the planet, and while the diamond planet hypothesis is famous, its exact composition is still being investigated. 55 Cancri e was discovered in 2004 by astronomers studying the star system 55 Cancri. The planet could not be seen directly because it is too far away and too close to its bright parent star. Instead, scientists discovered it using the radial velocity method, which measures tiny movements of a star caused by the gravitational pull of an orbiting planet. Later, astronomers observed the planet passing in front of its star, called the transit method, allowing them to estimate its size and density. In 2012, researchers suggested that the planet might be rich in carbon, leading to the popular nickname, the Diamond Planet. Since then, more observations have refined, but not fully settled our understanding of its composition. The planet is located approximately 41 light-years from Earth in the constellation Cancri. Although this makes it one of the closer-known exoplanets, it is still incredibly far away. A spacecraft traveling at today's speeds would take hundreds of thousands of years to reach it. 55 Cancri e is classified as a super-Earth, meaning it is larger and more massive than Earth, but much smaller than gas giants like Jupiter. Some of its characteristics include diameter, about 1.9 times Earth's, mass, about 8 times Earth's, gravity, significantly stronger than Earth's because of its greater mass, density, higher than Earth's, suggesting it is made mostly of rock and heavy materials. These characteristics make it one of the most interesting rocky planets discovered outside our solar system. Why scientists think it may contain diamonds? Diamonds are made entirely of carbon atoms arranged in a strong crystal structure. On Earth, diamonds form deep underground under enormous heat and pressure. Scientists originally believed that the star around 55 Cancri e contained a high amount of carbon. If the planet formed from carbon-rich material, much of its interior could consist of carbon compounds. Under the planet's immense pressure, this carbon might have transformed into diamond. Early estimates suggested that up to 1/3 of the planet's mass could potentially consist of diamond. However, later research indicated the star may contain less carbon than first believed. As a result, scientists now consider the diamond-rich interior to be possible but not proven. Even so, the planet remains an important example of how planets with unusual compositions may exist. Surface and climate. The environment on 55 Cancri e is among the harshest known. The planet orbits extremely close to its star, about 25 times closer than Mercury is to the Sun. Because of this, it completes one orbit in only about 18 hours. Conditions include surface temperatures exceeding 2000 Celsius, 3600 Fahrenheit, constant exposure to intense radiation, possible oceans or lakes of molten lava, no liquid water, no breathable atmosphere for humans. The side facing the star is permanently exposed to intense heat, while the opposite side is much cooler, although still extremely hot by Earth standards. These conditions make the planet completely unsuitable for life as we know it. 6. Scientific importance. 55 Cancri e is important because it helps scientists understand how planets form under different conditions. By studying this planet, astronomers learn how rocky planets differ from Earth, how carbon-rich planets might form, how extreme temperatures affect planetary surfaces, how planetary atmospheres evolve, how diverse planetary systems are throughout the universe. The planet also demonstrates that our solar system is not the only possible model for planetary formation. Other star systems may produce worlds with very different compositions. Could humans visit or live there? With current technology, humans cannot travel to 55 Cancri e. Reasons include, it is 41 light-years away. Current spacecraft would require many thousands of years to reach it. The surface temperature would instantly destroy ordinary spacecraft and would be fatal to humans. There is no breathable oxygen. The intense heat and radiation make survival impossible. For these reasons, scientists study the planet using powerful telescopes rather than attempting to send people there. Conclusion: 55 Cancri e is one of the most fascinating exoplanets ever discovered. Although it is popularly known as the Diamond Planet, scientists are still investigating whether it truly contains vast amounts of diamond. Regardless of its exact composition, it has expanded our understanding of how planets can form under conditions very different from those on Earth. The discovery reminds us that the universe is filled with extraordinary worlds, many of which challenge our understanding of geology, chemistry, and planetary science. Future space telescopes and improved observation techniques may reveal even more remarkable planets and help determine whether 55 Cancri e truly deserves its famous nickname.